All right, hereby call this September meeting of the Homebrew Robotics Club to order. Um, this is a very exciting meeting. This is our 21st annual um, HPRC Challenge Phase 3, where the whole meeting is a show and tell meeting. And so let's go ahead and get this party started. First thing we'll want to do is robot news. Any robot news out there that anybody wants to report?
GPT has released an app for phones that allows you to talk to the AI by voice and respond by voice and supposedly see pictures. I haven't tried it yet because I haven't been able to load it onto my phone. Either it's not available or I'm just doing it wrong.
I did too. It didn't enable for some reason.
Didn't enable, yeah.
You guys using iPhones or Android?
iPhone.
Android.
Fascinating.
I found a 3D printer that can print like a small volume, but it can scale in 5 minutes using a projector and a rotating disc. It kind of works like a CT scan.
What is that again, Oren?
A 3D printer.
And what's different about it?
The print time. You can print quite large volumes in around 5 minutes.
Okay. You got a link for that?
Let me find it real quick.
Yeah, you can put it in the chat. So I've been talking about a Unitree LiDAR that I've seen. I'll put it in the chat here. But let me share the screen here. And this Unitree 4D LiDAR, the fourth dimension is velocity, from what I understand, X, Y, Z, and then velocity. This is $450. These guys make quadruped, and they've recently released a student edition quadruped for like $1,600. And they also have a humanoid. Pretty interesting stuff going on with Unitree. You can go back further in the URL there and take a look at some of their other products. But I thought this LiDAR was outstanding, $450. And they say 360 by 90, and that looks something like this. It's a dome. It's a half dome. Okay. And what did they say here? 30 meters. That's outstanding. So this is a pretty interesting LiDAR, new LiDAR on the market.
What about the Tesla robot?
What about it? You got any new news? They had a new video out. I didn't really take a close look at it, but Tesla. There's a movie on Hulu called Robots, where the Tesla robots are apparently the standard. It's pretty hilarious. What else? Any other robot news out there?
I guess this counts. I found a 3D printing project that makes infinite, like a self-replicating 3D printer, with the caveat that the build plate can be infinite build size because it prints its own legs.
So this is another 3D printer?
Yeah, another 3D printer project where it's like kind of putting cards inside of each other. I don't know. It's hard to describe, but it prints its own like Z axis. So you could like make it scale up infinitely, and has some really interesting properties.
Cool. Yeah. Again, if you can find a link on that, just post it in the chat, Warren. All right, let's move on into club news here. Club news, we've got Marco. Can you talk about Maker Faire?
Do you have a microphone here? The judge listening. Yeah. On which side? This side?
Yeah.
Okay, yeah, so we are approved for the second weekend. And I have a couple of signups already from people. If somebody is not on the list yet, but would like to come for the club, I will ask for more tickets tomorrow. I do not know how many I will get.
Just the second weekend?
Just the second weekend. So around the 20th. And
Is that October
yeah.
20?
October 20th, yeah.
Okay.
Or basically Friday to Sunday, whatever that is.
Yeah, and it's cool that robotics will be the focus on that weekend. So all the robot folks will be there.
So am I to assume the HBRC will not be there on the prior weekend, the 17th or something? 16th, 17th, 18th?
No, at least not officially. I don't know if some members will show up there, but we have to boost the table only for the second weekend.
All right, thank you.
So, yeah. The people who are running it seem to be mostly new, and let's see how things go.
Very good. Thank you very much. Marco Walthall, ladies and gentlemen. All right. Club news. I did something interesting today. I started the Homebrew Robotics Club of Tallahassee, Florida. At Making Amazing or Making Awesome in Tallahassee. It's a maker space. And I joined a couple of months ago. They got, 3D printers and wood shop and sewing class and all that. So I set the Homebrew Robotics Club to meet the last Wednesday of the month. Imagine that. And we had our first meeting today, and there were 4 of us, including myself. And I went through my cavalcade of demos and so on and so forth, and everybody was very excited. Looks like they'll be back next week. And so we got a homebrew club here in Tallahassee too. What are the club news out there? All right, let's move on into what I need help with. Folks are working on stuff, I assume. You have questions, you need help with something specific. This is a good group to ask those questions to. I know we've been doing a lot of troubleshooting. I've got Alan and Ross Lunan and I are starting to work on a mock turtle project. And so I've got the Create 3 that I'll be demonstrating later and implementing Ross on it with an LD06 and trying to map and navigate anyways. We'll see how that goes. You're looking for trouble, you come to the right place. Anybody else have a particular problem or question they want to put to the group? Going once, going twice?
Yes, I do. I do.
All right, Thomas, what you got?
Is anybody else coding GPT, ChatGPT, any of the siblings of OpenAI? Is anybody else coding any of that into their robots besides me? And Jim? I know Jim's been using it. Or something similar. I don't know. Jim, are you there?
Yes.
Have you been using OpenAI's ChatGPT and all that?
Yeah, I have. it's been a few weeks, but been using it for that Cooper, that whole Cooper project, and on Big Orange. I use it from the Python API to OpenAI, um, and through Unreal Engine is also a C a way to connect to it through a C plugin. But yeah, it's you just have to it's a fairly well documented how to use it, and I haven't had any major trouble with it.
All right. How about vision? Have you got any vision through it? Because I know they've been working on that.
Oh no, I haven't done anything advanced with, I mean, like that vision. Just sending text, and I've used the different models that the GPT 3.5 Turbo is the normal one that's what it's technically called when you call that the API, and then they have a 16 kilobyte one that you can send a huge amount of context instead of just the 4K. It's double the price, but anyway, yeah, I haven't done vision and I think they've improved their API, and they send out email every once in a while with like, if you're on their mailing list, they say, oh, you can now use this new feature. I haven't done all of them.
I think mine must be going to the spam because I'm a paying customer. Anybody else in the club, or is it just Jim and I?
I use GPT ChatGPT a lot, but I haven't seen there like any API stuff related to like, the vision being exposed. It looks really interesting. Have you guys dealt with the I think it's called inference engine or something? Where ChatGPT can run code in the browser, or, like run code.
I haven't
I
tried.
I haven't tried any of those advanced features, but yeah, they're very, and there's functions. The functions thing I've been like to try, because you can have it call functions, and you can have it, yeah, it's connect it to your real computer, to your files, to your whatever, to outside of its own realm. So anyway, but that's a whole other meeting. I don't want to hog here.
Very fine. Thank you very much. You can post your specific questions on the mailing list, and that's a great place to get technical feedback. Any other what I need help with?
Well, what I'm doing is still trying to do a Robo Magellan unit. I've got good info. I watched Marco's old video, and trying to put that together, but we got help on the mailing list.
Very fine. All right. So, say Ralph Hips, the hippest Ralph of all. We've got you up first here with video on TableBot, FloorBot, and ARM challenge. Is that okay?
Sure.
Okay. Before we get into it, let me tell the story of the HBRC challenge. 21 years ago, we were lamenting the lack of building activity in the club. We observed that activity increased with contest. We had a line following contest, a maze busting contest, and we knew there were dozens of robots in the club, but for the most part, they'd been demoed once and sit on a shelf, and that's kind of how it was. And so we wanted to do some kind of contest, but we didn't want it to have any setup where you had to bring things and set stuff up. That was always a hassle. We were meeting in a library at the time, the Santa Clara, the Cupertino Library, and we thought, let's do tabletop soccer. We thought, we'd put nets around the table and catch the robot when it fell off, and said, no, that's set up, and that's when it was born, the TableBot. TableBot is a robot that survives, lives, and plays on a table or pays the price. Now, how do you get to tabletop soccer? That's non-trivial. You get there in phases. And so we developed the phase 1, 2, and 3, where phase 1 is the robot goes from one end of the table to the other and back. Phase 2 is push a block off the edge of the table. And phase 3 is to move the block into a shoebox mounted at the end of the table. And we didn't specify the size or type of robot or anything. We didn't specify the size of the table, the color of the table, or anything, or the shoebox. I've seen some awful big shoeboxes in my time. But the idea is to show your robot in its best light, and to get some of these robots that had already been demoed once and kind of set on the shelf back out and for another thing. So and the next year we developed it into the HBRC challenge, and we still try to do the phase thing, where this is held 3 times a year, March, August, and March, June, and August, March, June, and September. And the concept is you're supposed to do a phase 1, 2, or 3, to get to a finished robot. That's our stock in trade, but it's become this, show up with what you got. It's an opportunity to create, you build towards it. I know a lot of people put time, energy, and effort into this thing, and it just didn't work out at the end. So, but anyways, because of the deadline, you did put some time, energy, and effort into it, and I do appreciate that. So here we are at our 21st annual, and this is phase 3. And as I mentioned earlier, let's get this party started. Ralph Hips, ladies and gentlemen.
All right, well, I need to share my screen. Since I'm here in the room, hopefully this will work okay.
Screen share, oops, sorry. Screen sharing is on.
Okay, and this thing, get this thing out of the way somehow. Okay, so right, can you guys see my screen?
Do not see your screen. Did you select the share screen?
I'm not sure. Let's see, share screen. Oh yeah, it had to be allowed. Okay, share screen, desktop. Okay, share. Got it. You can see it now?
Now we see your screen.
All right, great. So this first video is Bile, my robot Bile, doing the Floorbot challenge. I'll just play this, and I'm not sure if the audio comes through on this or not.
It said share screen. That was a share audio.
Share audio.
It's okay, you can narrate it, Ralph.
Yeah. Anyway, so this is Bile. He's basically doing
I'll do sound effects.
that's what he sounds like when he's running. And this is a level 1 Floorbot, so he basically goes across the room and back. And I started him on the edge of the hardwood. He's actually doing extra credit. He's going all the way through to the far side of the kitchen, and that was his victory dance. So basically, just using distance sensor to see when he gets close to. Again, he goes to the couch up here, and then senses that, turns around, and comes back. So it's a level 1 Floorbot. Basically, the trickiest part is calibrating the 180-degree turn using the encoders on the 2 motors, getting him to do that reliably, and so forth. So that's pretty much the secret sauce for him. So that's that guy. Any questions on that at all?
So this is a Floorbot. A Floorbot is a robot that's too big for the table. And there are 3 phases to the Floorbot challenge. Phase 1 is to go from one end of the room to the other and back, which Bile did. Phase 2 would be to identify an object in the room, and phase 3 is to fetch that object. I think we've had 2 or 3 people actually attain phase 3.
Really? Huh. Oh, there you go. Yes. So, and this is the this chassis is the DF robot tank chassis, I think, from those guys over in China.
That's
Anyway.
excellent, Ralph. Thank you very much.
Yeah. And then I've got another one here on the TableBot, and you'll notice the
That looks
chassis
like Bile also.
It is, as a matter of fact. As a matter of fact, it is. So this one.
Bile's a multi-challenge robot.
He is. That's right. You just download different code and you can do different things. And this one is level 3 table bot. So he has to not only go down to the other end and come back, but he has to detect a block on the table and then also detect the goal on the table, the shoebox, and to push the block into the shoebox. So I've got a couple of small quote unquote lidars, little laser rangefinders on this thing. To one down low, you can see it there just below his eyes. That's the one that detects the block, and then the one up on top is spanning back and forth, does double duty. That looks for the shoebox and also scans downward across the table to look for the edges of the table so it doesn't drive off the edge and do a level 4 table bot. So yes, so that one's doing double duty. Yeah, and so that's that. And then let's see, robotic arm.
Could you say
Yeah.
what kind of LiDAR that is? That's one of those fixed fixed like grid LiDARs? Or
No,
solid?
no. So you might not be able to see it real well, but there's a if you look right here, you can see there's a little red PCB here with the body of the LiDAR, I guess, on it here. And so it's it's one of those VLO 53 or VLOX 53s, one of those things.
Time of flight.
Time of flight sensor.
Yeah, time of flight.
Yes, that's what it is. Yeah, time of flight. Yeah.
But it's is it a grid, like a 4x4 or some kind of grid of return values, or is it just
Well, there's flavors on these. I started out with a single point version. This one I think actually has I forget 16 areas that it can receive this reflection back from and try to narrow it down. I've tried using that to do something interesting with, but it was not real effective. So I just use it as a single point.
Okay.
Yeah, time of flight sensor. And so that's why you'll see it panning back and forth here. Well, at some point anyway. Right now he's looking for the block and so forth. So, but once he gets going, you'll see this thing pans back and forth. And once he gets going, yeah. So now he's getting ready to start panning back and forth. So what he's doing there is basically, since it's not a point cloud or a wide 64-point sensor, he has to scan back and forth across the table, and then I use a little trigonometry to figure out what distance he should be seeing, and then if it's longer than that, then that's probably the edge or end of the table, side or end of the table, and I should turn away, from that so I don't fall off, basically. And so that's what I'm doing with that.
And the cube is the cube is being detected by another distance sensor there, the lower one.
Yes. So when he turns around, we can see that, and that lower one, I call it the chin sensor or whatever. You can see it here. That guy, at the beginning, he turns left and then right and uses that to look to see if there's a block on the table. Obviously, he's looking sort of parallel to the table, so he's going to get very long readings unless there's a block in the way. And then once I detect the block and I go up to it, he can detect when I've captured the block because the distance will go basically to 0. So then I know I've got the block captured in here in between the two hook'em horns, and then I can stop and turn and head toward the shoebox. So that's what that is.
What is that one? Is that infrared or?
It's a similar infrared time of flight sensor. It's not as fancy as the VLO type, or maybe it's an earlier version one, but triple check. It's like a 1 meter sensor or something instead of a 4 meter sensor like the one on top. But it's the same kind of infrared time of flight thing. Yeah.
Very cool.
Yeah. And then it's going to be hard to see here, but this white thing here, kind of in the middle, is actually a pixie cam, which for a while I was actually trying to use that to detect the block. And now that I mentioned it, he may still be doing that. So when he powers up, you'll see the white lights come on. Those are the lights for the pixie cam. So he uses those to help kind of even out the lighting. And he can spot the orange background of the shoebox here, and then hopefully the yellow of the block. And if he detects both of those objects, then I have a couple of lights in the back that light up to say that he's detected them. And then I turn to the left and right to see what the range is to the block, what angle I need to drive off in. So if you kind of, I go to the beginning here, when he first powers up, you'll see the white lights come on, and that's the Pixie Cam looking at the what's out there. And the Pixie Cam can detect the orange shoebox and the yellow block. And then these two lights in the back light up, depending on what he's detected. One or two or none of the lights will light up, depending on what he's seen with the Pixie Cam. And then once that's done, then he kind of turns until the rangefinder picks up the block on the table.
Oh.
If I hadn't detected it with the Pixie Cam, I wouldn't bother to make that turning maneuver to see whether it was left or right of me and at what angle. I would have just figured it was level 1, and I would have gone to the end and come back. So there's sort of three sensors here that I'm using.
Yeah. So the Pixie Cam, you running some OpenCV type code? Or
Not really.
Does it have its own thing?
Yeah, the Pixie Cam has its own thing. There's an NXP processor on the Pixie Cam, and it's running some embedded code, and it's basically a color blob detector.
Okay.
So it's therefore somewhat vulnerable to changes in lighting. So it's not the most reliable thing in the whole wide world. But if you calibrate it right then and there and then use it in the same room, same lighting, it's not too bad. But if you calibrate it at home and then come to the Robot Club meeting, all bets are off. It may or may not work.
Open the drapes.
Yeah, I've
open the
seen that
tray,
before.
right, or cloud goes by and makes it darker inside the room, because the sun's not coming in. Things like that. It's a little finicky. Yeah.
Okay, cool.
Yeah, it's interesting. Yeah. Right, and then another one we had in the past was we still have is the robotic arm challenge, and this is Marvin with my arm number 2, and he's going to pick up this purple rock down here, and it weighs 1.1 pounds, so it's a little bit challenging to pick up something that heavy, but he's got a fairly good-sized arm, and with a lot of expensive high torque servos, and so this is a level 2 robotic arm challenge. So I'm picking up an object from a known location and moving it someplace else. And in this case, there's a bucket over there on the side of the bot where I drop objects that I pick up. So this is level 2 arm challenge, not level 3. Level 3 requires an object in an unknown location. So you have to find the object. It's the first step.
Phase 1 is build a robot arm that moves or waves. Phase 2 is pick up an object in a known location and move it to another location. And then 3 is pick up an object from an unknown location and place it in a container or known endpoint location.
Yeah, exactly. Yeah, and you may recognize this. Some of you may recognize this sample here in the background. Yeah, this is the white cylinder with the NASA thing.
That's space debris or something, isn't it?
Yes, exactly.
Captain
Right.
Hook's
They want
hand.
their purple rock back.
Huh?
In NASA call, they want their purple rock back.
That's right. Yeah, that purple rock was one of those NASA samples as well. That same color paint and all that.
Yeah.
Yes, exciting stuff. And last but not least, I don't think we have a humanoid robot challenge, but I have a humanoid robot. I thought I'd just show this. And he's just standing up from laying on his face, basically. It's all this is, but getting started.
We need a humanoid robot challenge, Ralph.
I think we need a humanoid robot challenge. That would be cool.
You should head that up.
So that you win.
Yes, exactly. Yeah. So yeah, this was an interesting one. This was a kit I bought a long time ago, and then I bought some cheap servos for. And one of the challenges was he was a lot taller before. There was like another set of servos in the leg. I think there was he had like double jointed knees or something, and it made him a lot taller, and so he was much more unstable. And you can kind of see here he's not perfectly smooth. He wobbles a little bit when he kind of stands up, and so that's one of the things I have to be very careful about standing up, because he wobbles a little bit. There you go, see, and stuff like that. When he was taller, when I had the full kit with the really long legs, he was really, really dicey, really unstable. So he could fall over very easily. So one of the things I did to try to kind of help make him work a little better is I just shortened his legs. So he behaves himself. So he's basically got ankle servos and hip servos, and that's it. So, and that's it for my videos.
Ralph Hipps, ladies and gentlemen.
Thank you. Right.
Sergey, you out there? I see you, Sergey. You need to unmute yourself.
Yeah, I need to share my screen if you want my presentation. Yes.
Okay, yes, screen sharing is enabled.
Okay, let's see. I hope you can see my screen now, right?
We can see your
Yes.
screen, Sergey.
Okay, so my name is Sergey Grichin. I've been with the club for a while, so most of you probably saw my face. This presentation is in the category of show what you've got, so there is no really challenge or whatever. And I'm probably in the wrong place now with the presentation, because you guys are doing all the ROS2 stuff and the AI stuff and everything else. And I'm working in a completely different environment. I'm working in the PX4 autopilot code base. So the code comes from this project. I'm not sure if you can see details on my screen, but this is a PX4 or Drone Code Foundation web page, and it develops 4 code bases. PX4 Autopilot, which is actually equivalent or to some extent to ArduPilot. You probably heard of those. Mavlink, which is the connection between the ground stations and the autopilot, onboard autopilot, and also Mavlink can be used as a connection for ROS controlling the vehicle that is in turn controlled by autopilot on the low level. Mav SDK allows you to program Mavlink messages so that you have that wonderful, useful environment to write your own code in Python or whatever. And Ku ground control, you will see on my screen a moment later, it's a ground station. Or ArduPilot has its own ground station type, so I'm not in the ArduPilot culture. I'm completely in that, ecosystem of the PX4 and Drone Code Foundation. So what I'm doing is I'm basically trying to get my loan mode using a I'm trying to click on the other screen here. Using the real lawnmower. Let me see if I can do this. And this is how it looks like. So you see that headless zero-turn mower, gas-powered, noisy, smelly, 23 horsepower, dangerous, and it mows my lawn automatically.
Is it doing it in parallel lines?
Well, that's a tricky question. I prefer to take the fifth on that. And I can talk about that, I mean, it's an interesting question indeed, and it's been a difficulty for me, strangely enough, riding straight lines is the most difficult part of controlling that beast. So, okay, I'm done now with the live demonstration of my old video. Actually, this video has been there for 2 years already. So let me move to a more live demonstration of the current code of the lawnmower in Gazebo Classic simulation. So what I do on my screen, in my screen here, is I run the make command, which says run simulation with my model.
Communication regained. With light fail. F2 missing data. Disarm. Position flight mode.
And what you see on my screen is the model of the lawnmower. So it kind of represents the body of the lawnmower, represents the wheels. There is alarm and the engine kind of indication. And then there is a cutter that is represented by this little flag here. So you will see it all in action. And now what I'm going to do is I open the ground station, and hopefully, let me see. Okay, leave plan on the vehicle. And there is already a mission here that is programmed kind of in the ground station. You can go to plan screen, you can put the waypoints on the map, and this is actually my house and my lawn here. And then the starting position of the lawnmower will be represented in coordinates, and obviously is reflected here on the map. And then it will go along the mission here. We call it mission in PX4. And it will execute the mission going from waypoint to waypoint. So let me start the mission.
Mission flight mode. Armed.
Just a moment.
Hey, this is Gazebo, but it's not Ross, right? So this is a
Gazebo is a very universal tool.
Universal.
If you want to simulate anything, you use Gazebo with anything you want. There are plugins, so-called, which are standard part of Gazebo package, and you just program your messages against or calls against that Gazebo plugin. So you can control joints, you can control things like differential drive if you want to. You can control multi-copter plugins. There is a lot of standard facilities there that enable.
So does the satellite view imagery come from the PX4 autopilot stuff?
Well, satellite imagery comes from standard databases, but what you see on the screen here is Q ground control. This is a ground station, which is part of the drone code. So it just gets the images from basically Google Maps. And that's why it looks so real. But of course, in Gazebo doesn't have that ability to get the image of my lawn. So it is simulated using just, standard colors and patterns and everything else. There is that concept of the world that you can put your model in. So your actual simulation that you see on the screen, it consists of the world, which is kind of beautified, empty world in my case, but you can have a more sophisticated worlds, of course. And then I put my model, and then I call, or the PX4 simulation module calls the plugins, and that makes the robot move.
I have a question about the I want to call it Arduino Pilot, but it's not. What did you have to do in terms of modifying the Arduino Pilot equivalent to make it work for this versus like an open, like the drone stuff? Does that make sense?
Well, the Drone Code Foundation publishes complete source code, and it is constantly under development. So you have branches for the previous releases, you have branch that is currently under development, which I use for my work. And what I personally do is I fork it from GitHub, and I compile it on my Intel Linux computer, and I can compile it for Gazebo simulation and run it as you see now, so it completely runs on Intel computer. But then I could use a different make command, and it will compile, cross-compile, and download it to any platform that is that can run PX4. So PX4 in this case runs on my lawnmower on a Raspberry Pi 3B, and it is written in C++. It's very efficient. Its architecture is similar to ROS. So it's messaging, it's publish, subscribe, and stuff like that. Very well layered, very efficient code. And it is not taxing those little microcontrollers that drive the drones, all these Cube Pilot and Pixhawk. They are not very powerful. They are 300 megahertz microprocessors. So that's how it works. For me, it works as a cross compilation, and then I run the Raspberry Pi, and Raspberry Pi drives the zero-turn mower. Did I answer your question?
Yes.
And there are different sub build targets for basically rovers, for drones, for planes.
Yeah, it supports multiple vehicles.
Yes. So whatever you need. And that is true for the PX4 code base and for the Autopilot code base. My Robo Magellan rover is basically using the Autopilot code as the rover branch, rover build target, and that works for a couple of years now.
Tell you what, why don't we why don't we change up the lineup here? Marco, since we're in the mode for lawn mowing robots, why don't you go next?
I have one question, but Sergey, I noticed the line from L to 2, or from the launch to the 2 was an arc there. Does the system, is it simulating some kind of error accumulation or whatever GPS issues? Is that why it's not? I mean, how does the simulator account for real world situation?
It throws a little bit of random noise into all the sensors.
Okay.
And actually PX4 detects stale sensors. If there is no noise, then it will assume that the sensor is stale and it will not consider it. So yeah, it does emulate some deficiencies of the real world, yes.
Let's keep talking about lawn mowing robots. Marco, if you, is that it, Sergey?
I don't know how to, oh, to stop share. Okay, I found it.
Thank you very much, Sergey.
Oh, you're
Out there
welcome.
in
Thank you.
Alabama, mowing lawns autonomously.
Yeah, that's the job for real robots, you know.
What's that again?
That's the job for real robots. You know, that's what real robots should do. Mow the lawns.
Yeah.
Dirty, dull, and dangerous. Marco, this is your slide up, right?
Yeah, that's my screen.
Marco,
And
walk out, ladies and gentlemen. Go ahead.
I will walk back and forth here a little bit. So that's basically my base. Arduino, it is an Arduino, or originally Arduino based. No, that's fine. So this is actually my house and my you saw the app here. I tried to overlay the pattern over my front lawn, and when you saw, there are mostly basically tree covering everything, so it's very challenging for GPS, and that's basically just sped up to 25x, and you still see that it's stopping at points where it basically loses GPS signal or is not happy with the GPS signal and basically waits for better conditions. So eventually it will get to the tree. I did not exclude the tree just to make sure that basically the sensors detect it and it basically bumps into it and drives around it. And so, yeah, it could do exclusions, but yeah, I did not want to do that. So, and yes, it
Interesting
does.
wheels. What kind of wheels are those?
Those are right now basically hard plastic or aluminum clad plastic, I think out of a CNC cutter cut wheels. I want to bring this more to the Maker Faire as well, and I printed some TPU they are not on there just yet. So that's basically TPU, so that it can be a little bit quieter on the concrete. I expect at the Maker Faire.
Sorry, what's that made of?
TPU.
3D printed or?
Yeah. So that's
What, I'm sorry, what do you call TPU?
yeah. Out of.
Can you repeat the question there?
Yes, the question was just more details on what it's made out of.
Yeah, that's basically TPU.
TPU.
Sorry?
Some material you can 3D print.
It's basically flexible, 3D printable.
Printable rubber.
Yeah. So, and at some point it basically went around the perimeter, and now on the top you see basically my base station on the roof there.
Is that where the robot charges?
No, the robot charges in the backyard. That's basically its home with the charging station.
Yeah, quite the question on the GPS. You mentioned when it loses signal, it has an algorithm of some kind? What does it do? Just
It,
wait
it,
or
it basically waits. Yeah, because
it
yeah,
comes hot or does it move?
it depends when it's still kind of okay.
Yeah.
It's drives slower.
Mhm.
Normally it drives at 0.2 meters per second, so relatively slow.
Mhm.
And it goes down to 0.1 meters per second. And if the GPS gets lost completely, it will essentially stop and wait.
So if it waits long enough, it picks up a signal?
Yeah.
Signal?
Yeah.
Thanks.
At least that's the plan.
So far.
I have not seen it.
Has it worked once?
It
That's
has
what I was-
worked
okay.
for 2 years now. I cannot really let it loose on the front yard because yes, it's open to the street and everything. But in the
Is
backyard,
this, you say you're using a TPU, is that the actual Google product, tensor processor
No.
unit?
no, the TPU, the plastic, the flexible filament.
Yeah, TPU is a material as well as
Okay,
a.
I'm sorry, I got off in the left field. What processor are you using in that robot?
In that robot, there's currently an ARM Core M4, basically an Adafruit Grand Central Station, running essentially a large Arduino sketch. And it has an ESP32 as Bluetooth and Wi-Fi coprocessor. So
Okay, so the Ardu and Ardu mower is Arduino, huh?
yeah, it basically started out with an Arduino,
Okay,
moved
super.
up to an M4 by now, and at some point they basically tried to sell a consumer product based in around an banana pie. But I don't think they were so happy with it because, yeah, GPS is spotty, and especially in my front yard, I have days where it works pretty nicely, and then days where it
Well,
goes.
tree leaves are the wavelength. of the
Yeah,
GPS
yeah.
signal.
And basically the house, the 2-story house right next to it and everything. So then some days, apparently, I don't see enough satellites so that it's happy, and then it sleeps more than it does. So,
What about the I remember I worked on a GPS project for like steering goats, like a goat collar, and the GPS part was it drifted a bunch. And I'm curious if you've looked into what about those antennas that account for the offset and stuff?
I
Can't remember what they're called.
basically have a base station on my roof, on my home, basically. And that knows its position down to a millimeter. And so it broadcasts its position and its reception data, and the mower uses that to come basically down to less than an inch for most of its way. So it is basically
So you're computing your own differential GPS.
it's basically the normal RTK setup.
You got
And
the silver medal. You got the silver medal in Robo Games, didn't you?
I got not this year, but I got 2 gold medals at some point. Yeah.
You got the okay, very fine. Walter
What about
Marco Wolfau, ladies and gentlemen. Thank you very much. All right.
what about
That was awesome.
is the software the same? I wanted to ask a question about is your software similar to Sergey's then, or system, or not quite?
Not quite. It probably started around the same time. but it is different when I look at the pattern, at the map setup and everything. It was never designed basically with drones or any large area vehicles in mind. So it is really the path planning is more than almost like a 3D printer idea, putting down its first layer. And so it basically does everything relative to the base station. So I'm basically 15 meters east of the base station or something like that. And so that's how it calculates its points.
So in other words, just your own custom software.
Yeah,
Or
open source custom software, yes.
All right, thank you very much. Thank you very much, Marco. Next up, we have Scott Horton out of, Scott, you're in Houston area, aren't you?
Dallas area.
Dallas area, I always get that
Yep.
wrong.
Yeah, that's all right. Yeah, I was going to show you my outside demo using GPS, RTK, our Ross nav stuff, but I'm probably a weekend away from that. So having to fall back to some filler stuff. And so I thought I'd show this demo or this little project I was working on early in the summer before it got so hot. Let's see. Screen share. Okay, so hopefully you can see this Elsabot Jeep.
We can see your screen.
Okay, you see the Jeep though? Okay. All right.
Elsabot Jeep.
All right, I'm gonna just play this.
I'm Elsabot. My Jeep robot base can now navigate a looping path in the backyard using ROS 2 navigation. Thanks for watching. See you later.
So basically, it's pretty simple. I just created a little simple global planner just for fun that just essentially plots a looping course. So I give it several or a handful of points, and so it basically says, use those and just go to the next one. And it's using the regulated pure pursuit controller just to follow that path. And so the idea is it's like, self-driving for the grandkids. And the big Elsabot stuff on the back is really not being used for this demo. I don't have the perception stuff going. There's a Raspberry Pi where the seat goes that's actually doing all the control right now. And so, the stuff on the back right there is serving as more of a Wi-Fi bridge for the rest of it.
What do you use for steering? What kind of motor?
Those motors are just the stock motors, the 20, I think those are the 12-volt motors.
No, I'm talking about actually the steering. How are you steering it?
So I bought one of the motors. This wasn't designed for auto or power steering. And so I bought one of those power wheel motors for that and basically made a bracket underneath. And so I basically chopped the steering wheel and put an encoder where you can sense the steering wheel position, and then use that motor then being driven by the micro. And I put an encoder down below, pretty good encoder, and rebuilt the whole front end because it's real sloppy, and this was an old used one and the plastic was bent. And so I just went in and did a pretty good renovation on it just to get decent steering. The real challenge on this is the turning radius is so large it barely works in my backyard. If you just want to make a turn without having to back up. And that
Are there two motors in the rear?
Yeah, there's two in the rear.
Okay.
So anyway, that's pretty much that. Not too much, but kind of fun. And then just something I've been working on, a little project for my cat friend, and I'll just play this one.
Let's play. Hi, I'm Elsabot. I now have a laser pointer on my head that I used to play with my cat friend Boris. What's your plan?
Oh, that's awesome.
So yeah, those are simple. I just put a laser pointer on the head and make it controllable, and use AI detection to basically detect the cat. And whenever he gets close to the center, within the center of view, where the program expects the dot to be, it just moves. So it's just super simple. I was thinking of doing some behavioral cloning because I can play with a laser a whole lot better with with the cat. A human can really make the cat work hard, where a simple algorithm, they get bored instantly, and so I haven't decided whether I'm going to invest that much effort, but there's definitely potential for more sophisticated algorithms.
I
But
tell you,
anyway,
pet owners are a great market for robotics.
yeah. But anyway, that's about all I got. Yeah, not too much, but hopefully somewhat entertaining.
Yeah. Hey, Scott, I have a question on that. On the first one, you were saying that you wrote the planner, some planning algorithm to do that, to follow your course, your
Right.
waypoints. What was that called?
Well, there's I think it was just a sample. It was just a global planner. NAV2 had a sample out that was real simple. And I'm trying to remember what it used as its input, but I just changed it to where I could provide a JSON file with, some XY points that I figured out, just kind of determined. And then, the planner just says, okay, where am I right now? Find the closest one and basically get on the track. And then just go from point to point, just keep doing that, until it's told to stop navigating. So it's really pretty simple, but it's just kind of fun to learn, how a planner works, and, which, it's kind of in the devil of all the geometric details of, okay, where do I want it to go next? What kind of curves I want it to take. And this was super simple because really just had to say, go here. And then the controller takes care of figuring out, a control path, so.
But this was RTK, as far as the GPS.
No, for this is actually just using my indoor LiDAR, which works well enough in my backyard.
Oh,
and since then I've got, I set up an RTK GPS setup, which won't work in my backyard. My trees are too mature, and which is a real bummer. So I have to do it in the front yard, which is not as fun, to work out there, and it's hotter. In fact, I had to put that on hold for the last 3 months. It was just so brutally hot. Who wants to go out to 100-degree plus, temperatures and play with your robot, project. So, so now it's time. All right.
Very good. Thank you very much, Scott.
All right. Is this thing still sharing? I'm trying to say stop, but.
I want to remove the spotlight. Scott joins in on Chaz's AI and Gazebo Fortress meetings on Sunday. Dallas, right?
Yep, Dallas area.
Okay, next up, one of my most favorite people in the world, Damaris Davis, otherwise known as DD, engineering chick.
Hi, thank you.
Hey, Dee, how you doing?
Oh, trying to hang in there, and you?
I'm doing well, thank you. So good to see you. I understand you got a project you're working on. It's a work in progress, right?
Yeah, right.
Did you
also
know something else before?
Oh well, I also have my little mini welcome bot in the background doing the small.
That's good for a arm bot challenge phase 1.
Yeah. So she's just waving hi. Well, was waving. Okay, there we go.
What's her name?
A mini welcome bot.
This is a mini welcome bot. That's good.
Mini.
I like that. The welcome bot.
Yeah, because there's a large welcome bot behind me with a much bigger arm. And this one has the screen with the Raspberry Pi with the face detection. And if it sees a person, it shows the face here. But that's not turned on right now. So the mini one, I just have to plug it in. There's no setup at all. So
very good.
Pretty easy.
We're hard to impress, but easily amused.
Okay. So this Spot Micro I built like a year and a half ago. So I brought it to Robots on Ice, and I brought it to a couple things, but when I did bring it the first time on Robots on Ice, it was moving. I had a video there I can show a little later. I had it on the Raspberry Pi 2W, you know, the little stick of gum. One here, there's a there's a shield on top of it. Anyways, I wanted to transfer it to the ESP 32. So that's over here. There's a code base already for the kinematics of the Spot Micro on the Spot Micro webpage, and the code there. And some of the things I think I'm still working on is recalibrating the legs and such and finishing all the hookups. So that's basically been on a holding pattern on my to-do list for a while. But so it's kind of phase 0 because it used to be working and now it's in transition.
Is this Spot Micro AI?
Yeah.
Is that it? Okay, I'm gonna put the web page on the chat.
Yeah, there's multiple links, multiple versions of it. So there's no supports for this one. I like how it turned out. We actually made 2 of them, so my daughter can also build one if she so desires. But yeah, work in progress.
Very fine.
Okay. Thank you. If you like, I can turn it over to the next person.
Morris Davis, ladies and gentlemen. Thank you very much.
Yeah.
So is your daughter? How are the gosh, what's the humanoid name?
The humanoid, the in moves.
How are the in moves?
All right. They're doing their thing. My daughter's here thinking about upgrading them. So we'll see whether or not we get those tickets to the Maker Fairs to bring the 3 of them.
All right, sounds good. Looking forward. Thank you very much, Dee Dee.
Oh, thank you.
All righty. Next up, Jim D'Annunzio and Big Orange.
Hello. Yeah, so I have 2 videos to show today. And the first one is unfortunately it's a work in progress. Not I wasn't able to complete but it's for challenge 3 and of a floor bot. So Big Orange has done successfully completed challenges 1 and 2, gone across the room and back, and then identified an object, the remote control, and goes up to it. And you've seen that in previous meetings. And so now I put together a video of the bloopers. So hopefully, as you're easily amused, as claimed, this hopefully will do that. And there's a little bit of seriousness. There's some accomplishment that has been done here. So I call this the grab a bottle if you can. So here I'll start playing.
Hey Orange, retrieve the bottle.
Okay, I'll search for the bottle. Okay, I see a bottle. I found the bottle. Sorry, I could not get the bottle.
It's kind of funny.
Sorry, I could not get the bottle.
It's going crazy. I recommend always converting radians, degrees to radians. I was giving up on him, but then he did something right. And this is like a backup to redo. And finally, yay! So that's I've pieced together different pieces of that, of the whole process. And so I'm trying to get all of the, the in-between stuff is the hardest part. And it's transferring to a, from the camera, the Oak D camera, the lower one here measures the distance using it's a stereo camera. And then when it gets really close, I'm using sonar here for the capture. And the sonar is a bit fickle and I have to aim it downward. And that's where the challenge is in the last few inches where the camera can't see it anymore. Neither camera. There's one here, same as this one. But that's the challenge there, is the transitioning from different sensors to the sort of the close sensor and getting it all to behave well. Sonar is always, kind of an issue. And then the accuracy of the robot coming up. But I did get him to, you saw here, there's another clip that he gets even closer. And then I'm going to I've added code that sort of sweeps him back and forth a little bit to try to line up, because you don't have a lot of error, in the lineup with this claw. It's not very wide. I just had this part I had bought a long time ago, so I adapted and put it into where the front bumper or one of the bumpers is. But let me do the other video, then we can take questions. So this other video is a project that I've completed recently to use Alexa to control my robot. So an Alexa skill. So this is another short video.
Hi, today I want to show you a new feature I've added to Big Orange, and that is the ability to control him through Amazon Echo. We'll be able to give him commands through the cloud using Alexa. So let's try it out. Alexa, ask Big Orange his status.
Big Orange is located at the home and his battery is at 78%. I'm not sure what happened. Try again.
Alexa, ask Big Orange to take a picture.
Okay, Big Orange took a picture. It will be shown on his screen. I'm not sure what happened. Try again.
There's the picture he took. Not that interesting. And
Alexa, ask Big Orange to come to the office.
Okay, I've asked Big Orange to go to the office.
I'm going to the office.
So using the Alexa skill in the cloud, actually using this IoT core connected to an Alexa skill, a Lambda function, and this IoT core uses MQTT, this queuing transport protocol, essentially, and it's secure, which is nice. So it requires certificates and all that, and it's an uplink only, so there's no open ports on anything. So it's used for IoT and it's pretty good. This is the problem I have in my office there. And that just Big Orange's battery is dying. So, I'm sorry?
You need Marco's wheels on your thing.
Yeah. Okay, so that's that. So any questions about I think I posted to this group the my notes on Alexa skills. If not, I can do that again, but it's pretty good. I mean, it's satisfying to be able to control things via the cloud like that, and it's all it's all free for 12 months at least for the only part that would cost anything. And the Lambda used is is almost infinite, is for free as far as hobbyists go. So it's pretty neat. I just thought I had to do that.
Thank you very much, Jim. That was awesome.
Thank you.
Big Orange rocks. I'm a big fan. I'm a big Orange fan.
Thank you. Yeah. He likes your support. He thanks you for your support.
All right, let's keep this show rolling. Okay, before we move on, is there anybody that's not in the lineup that would like to do a demo? Going once, going twice. All right, Thomas Messerschmidt and Betty Nine, you're on.
All right, so this is Robot Betty 9. She's an animatronic robot that uses an Arduino and a Easy Robot board and a few other odds and ends. And she's going to sing a song because that's what she does. She's an entertainment robot. At least we hope she's going to sing a song. You never can tell. Sometimes she cooperates and sometimes she doesn't.
Live over Zoom, being streamed.
Now let's see. I want to test the voice.
Test 1 2 3. Test 1 2 3.
I have to make a small adjustment. Don't worry. This won't tickle a bit. Let's try it again.
Test 1 2 3.
There we go. The red lips are lighting up. Oh, and I wanted to send you the lyrics of her song, which are kind of garbled because the recording just didn't come out right. I'll put those in the chat. The song is called Barbie Robot Girl. I just got to find the lyrics. Yeah, see how well prepared I am.
You see how well prepared you are.
Yes, I'm very well prepared. Some days less well prepared than others. Oh, there they are. I found them. Computers are wonderful when they work. I'm paraphrasing Camp.
That's it. When it worked, it's great.
When it works, it's great. You got that right. All right, and let's see. Got that on. And I'm spotlighted. Here's the lyrics. I assume we don't have anyone under 18 in the audience. Your message is too long. What do you... I hate when that happens. I'm going to have to break it up. Let's see. Let's try that again. There's part 1. Part 2. See, if I was really good, I would have all this at the bottom of the screen as she was singing. Next year. Part 3. And let's see. All right. Well, there we go. Say hello, Betty.
Hello. My name is Betty 9. I am very glad to be here at the home Brew Robotics Club. I heard that this is a good place for robots to hang out. Ha, ha. A little robot humor. Anyway, for your amusement, I am going to sing a song called Barbie Robot Girl. Hit it, maestro.
Oh, that's me.
Sexy, automated, not automated, imagination, I am automated, you are automated, imagination, creation. I'm a boss, but it's sporty, I'm a real doll. I'm a doll, I'm real, see my breasts, I was with my wish to be alone. I am floaty, please, and keep my sunken warm. I'm a perfect girl, in a robot world, sexy automated. Not automated, category, to make more coffee, imagination, communication. Component delight, I'm ready. Component delight, I'm ready. Component delight, I'm ready. Component delight, I'm ready. I'm afraid, so I'm this way. I am plastic, I am steel, still my coat, it's so real. And I love my clothes, so I can't freeze up. But I'm here, there's no fear, I love you, real. I'm a toy, I'm a toy, I'm a toy, but always yours. Component delight, I'm ready. Component delight, I'm ready. Component delight, I'm ready. Component delight, I'm ready.
All right.
Well, was that fun, guys?
That was awesome, Thomas.
All right. Glad I could entertain.
Easily amused.
Amusing is everything.
Actually, let's I've got some uncanny valley myself here. Let's see if I can get you guys know Rocky. I used to have a transmitter around here somewhere. Anyways, I showed him at the Homebrew Robotics Club of Tallahassee. Let's see here. Hey, I do have a transmitter. All right. Continuing on with the Uncanny Valley Creepy Robot Show. There's Rocky. This one's always fun at Halloween. So there's Rocky. And let's see, I guess I'll just pick it up from here. Let me share my screen. Oh, with the Ross discussion group and Ross, Luna, and Alan Fetterman, Dr. Fetterman, have been working together. We're gonna produce a book called the Mock Turtle. Of course, Alan's already written the article 3 times for Servo Magazine. But so this is a Create here. This is a Create 3. The Turtle Bot's based on the Create 3, and it's actually a pretty interesting robot. Those eyes aren't real. But basically, when you turn on a Create 3, I've got the LD06 LiDAR there, Velcroed on with a Raspberry Pi. But when you turn on a Create 3, let me share my screen. Basically, it exposes these topics. So I'm sharing my screen. Actually, here you see the ARVIS. We had some trouble with mapping, and it kind of came and went at the Ross discussion group, and I got my host files right, and I don't know, the mapping came and went regardless. I've been doing this with my bot deck also at the Making Awesome in Tallahassee. So I'm a bit betwixt and between. But here I'll drive it around. Basically, this is just showing the LD06 LiDAR on the Create, and I'm not navigating. I'm just driving it with teleop keyboard. But this is some of the stuff we work on at the Ross discussion group. Here's the Create 4. Here's the Turtlebot 4. It's built on the Create, and they've got the LiDAR. They use a RP LiDAR and the OT. Actually, the big one is the OT Pro. We're going to be using an OT Lite. But anyways, what I wanted to show was when you boot up the Create 3, basically it sets up a hotspot. You log into it, you tell them about your Wi-Fi network. Thereafter, when you start the robot, it runs these ROS 2 nodes. Because I got a hell of a lot more in there because I got RVs going on. But regardless, let's do ROS 2 topic list. Yeah, okay. So this has got a lot more topics in it because I'm running RViz. But the point is that when you get a Create 3, it's not cheap. They're $450. And they're basically refurbished Roombot i3s. But it's a decent package where you boot up and it exposes all of these ROS topics, not the least of which is command velocity. So out of the box, you can run it with the teleop twist keyboard. So this is where we are currently. Actually, I've been ahead on this with this project. Again, you can see it driving around the LiDARs set up on the camera. And well, we'll be back on that one. I'm going to stop the share right now and exit out of this. And I'm going to show the Lino robot. That's another project we've been working on. The Lino robot, it's when I put together the prototype of the smart table in my book, Homebrew Robots. It's dawned on me that I need bigger wheels for carpet. So I'm trying to get 5-inch wheels. And the goal is to create a tray table that can reliably get from one place to another. I think that would be useful in the home or a business. And so let me shut all this stuff down. And I want to show you where we are with the Lino robot. Oh, before I do that though, let me show you something that I did at the Homebrew Club in Tallahassee. Okay, let me share my screen one more time here. Boom, boom, boom. And you see that?
Yes.
Thank you. All right. So when I was at the Making Awesome in Tallahassee, it's a makerspace. $25 a month, you can't beat it. They have 3D printing and sewing classes and wood shop and so on and so forth. So I put a stake in for the Homebrew Robotics Club. We had 4 people show up. It was pretty cool. But I demoed the bot vac here. You guys know the story. I drove around. I created a map. This is the classroom at Making Awesome. So I drove around. I made the map and navigated and showed some Arduino-based robots and the table bot and all that kind of stuff. And they were interested. So we'll be meeting again next month and see how that goes. So let's see, here's the mock turtle, the one that I just put together here. And actually, no, this is, okay, there's the mock turtle. Yeah. And so, yeah, it's basically 12-inch dowels and a 12-inch round put on the table. And I've got the LD6 LiDAR there. We'll be putting an OAK-D light. And so you want to keep track of that project. So one last demo here, and this will be the Lino robot. Lino robot, let me put the link in the chat, is started off with Mark Womack, suggested that we have a standard raw space club robot. And so it ended up with all of these great resources and suggestions and so on and so forth. The thread went for a long time. But what kept coming back to me was the Lino robot, where if we were ever to create a standard club-based if we were ever to create a standard club raw space robot, it's like Lino robot is what that should be. So let me put this in the chat. I think I may have gone a bridge too far here. I can't get to the chat. Did that terminal window come up on the screen there? No. Ooh.
Why do you call it a mock turtle?
Because Turtlebot is trademarked and it's been produced by ClearPath and Robotics and so on and so forth. And so Mock Turtle is, having fun with it. And it's a reference to the Mock Turtle of Alice in Wonderland.
I see.
So I have a problem here. My screen seems to have locked up. And let me just see if I can unlock it. Stop screen share. Okay. I'm gonna do something drastic here. See if I can log back in. Okay. Stay co-host. Okay. Let me see if I can share screen. Okay. So say, Thomas, is there any way you can clear that stop share? Can you hear me, Thomas?
Yeah, I'm looking for it. Share screen. Just by sharing myself. Let me double check that.
Because it seems to be hung on my screen.
You've crashed Zoom.
All right, well, I'm going to share mine real quick, and then we'll go right back to yours.
Hopefully.
Okay, you're seeing my screen now?
Yes.
Okay, I'm going to stop.
I still see that old one.
Yeah.
I Camp saw my screen. Try again, Camp.
Yeah, it ain't happening.
Maybe it's on your end then.
Well, except that we're all seeing it, so it's got to be in Zoom somewhere.
Pull the plug on that that Linux box.
I did just now. We'll see if this screen clears up. If not, I'm afraid that's about it with screen
That's
sharing.
a new name for zombie process or whatever. It won't go. This is just in time for Halloween.
Don't get me started. I hate the Zoom application. I love the browser, and it forced me into installing the app, and I don't like the way it works. And I don't like this. It doesn't look like that screen share is going away, does it?
Wait, what? You don't like the Zoom, the whole
You don't
Zoom
like the browser or
experience?
the Zoom app?
There you go. What happened?
There it goes.
Okay, I've rebooted the computer.
It was holding on for dear life for that.
Yeah. Yeah.
When in doubt, turn it off and on again.
I unspotlighted you, Camp. That was part of
the most common
Oh.
troubleshooting technique in the world.
Gotta have the dead man switch.
Yeah, you know, I kind of miss the old computers with the big red switch. Remember that, guys?
Yeah, for Robo Magellan, I'm supposed to have a dead man switch.
That's right. Okay, let's try this Lino robot one more time.
Look here.
There it is.
Whoa.
Yeah.
Yeah, that's it. As long as you keep your feet away from the blades.
All right, let's do this.
Don't go a chasing a lawnmower. Yeah, that's a case where you really need the you need an RF kill.
If anybody's interested, OpenAI has a really high paid job for turn off all the servers in case it becomes self-aware.
Yeah, the sentient alarm.
So this is the Lino robot. It's really a good example of the URDF, so that can be used in gazebo, and then they also have a physical robot component. I'll just go ahead and kick off Lino robot here. This is the gazebo. The original Lino robot is a 10-inch base with 3-inch wheels. We've modified it thanks to Mike Wimble and Marco and others to be a 20-inch square with 5-inch wheels, and we have a tabletop and legs on it. I flip-flop the LiDAR in the camera because LiDAR should be down low. Obstacles rise from the ground up, not from the top down. Here is the SLAM toolbox with RViz. And let me just set this thing so that it's we can get the 3D on it. Oh, interesting. And we add some more things. The camera, the depth camera, real sense in this case, and let's get the local cost map. And the global cost map. And the path planning.
Features of visualization. Yes. Which one? What is it you're trying to demonstrate, Ken?
Yeah, Camp, what are you showing us here? Is he on mute?
Lost his audio.
Huh?
Turn
We
the
lost-
speaker.
Camp, we don't hear you.
Are you speaking? I can hear Jim.
I don't hear him.
Yeah, me neither.
Right, it hurt.
He doesn't even seem to be. I can see his screen, but I don't see him. Participant list.
I did it in all caps.
Yeah, which the host is muted. At least one of them.
Yeah.
Thomas Camp.
Yeah, but Thomas will be back.
We might just hear cussing if he unmutes him.
Camp in Tulsa is muted.
Right, that's muted. Where's the other camp?
Yeah. I don't know. I don't see him.
Oh, he got his other connection dropped or something. He had two.
Yeah, that's what I think. We lost him.
I think
But isn't the screen from the one you think we lost?
No, I mean this is his other maybe he's using the other one for voice and this one is for video. I don't know. I can't keep track of his connections, but
wave in front of your camera, see if you can get his attention.
oh yeah. Let me start mine.
Camp in Tulsa is a different camp.
Yeah, I like it.
Camp. We have a lot of lockups today.
Yeah.
Where's the dead man switch?
We have an e-stop.
I'm back. What can I do?
Oh yeah, Thomas, can you figure out how to contact Camp because we can't hear him?
Oh yeah, I have his cell phone number.
Oh, that's a good idea.
He's still.
So, yeah, go back to old fashioned.
So let's still figure out how to use this live posting.
We can't hear you. There we go. I just texted him.
Yeah, he just stopped. It just like something. I think when his connection dropped that he was using for audio, maybe. But can you Hey Thomas, can you unmute?
Yeah.
Can you unmute Camp in Tulsa? His connection.
No, I can't unmute. I can only request to unmute.
Oh,
Camp
well,
in Tulsa is a different camp. It's not the same camp.
Oh, that's actually a different person, you mean?
Yes.
Oh,
The one in Tulsa is a new refined camp.
Yes.
So camp it just dropped entirely. You're saying when I went to the rest. Okay, well I guess I'll carry on, or somebody make her next.
Well, where was that screen coming from then? That was Camp, right?
He must have rebooted or something.
I bet you he went offline, guys.
Oh, but that screen that just went away, what name was that under? It wasn't Camp. It was
I don't know. I just got back a couple seconds ago.
Yeah, the host
Oh well.
It has multiple
All right,
screens.
my can you hear me?
Oh, there he
Yeah,
is.
Do we have any other? Do we have any
Oh, he was
other,
as HBRC host.
That's right.
My
Is there any other?
I
Any
think
other
he's having
challenges?
trouble with his
Todd?
bandwidth.
We lost
Are there
you,
any other
Camp, like
challenges?
10
What are
minutes
we doing?
ago.
Just when I took a break.
Yeah, that was perfect timing for the whole meeting to go awry.
Okay, well, we done?
All right, we're back. We're back.
done?
All right. Anything else this evening?
You can send us a
We're done.
video of your presentation. Upload
Did we
it.
have fun? Come to the Ross discussion group.
Oh, tomorrow. Got an announcement, Cam.
Oh, tomorrow.
Tomorrow's the Big Sig.
Big Sig.
Oh, okay. Voice Intelligence Group.
That's right.
Okay. We've got 3 SIGs now, the Ross SIG, the Builder SIG, and the Voice Intelligence Group.
Hey, Thomas, is there an agenda from Martin Trippett talk or something, anything?
No agenda. It's
open.
Open discussion.
All right.
What is that exactly? The meeting?
We talk about AI as it relates to verbal input and output, and video now, but we didn't change it. We didn't add another V to it.
Verbal intelligence group, right?
Otherwise, it'd be verbal video intelligence group. It'd be VV SIG or V squared SIG or something.
And it's done over Zoom, so it'll be Vava Zoom.
Yeah.
That's right. It's on Zoom. Every month, last Thursday of the month.
There's a lot of the Voice Intelligence Group videos in my YouTube channel. I just put that in the chat there.
Okay.
All right, what else this evening?
We done?
I think that does it. We had some fun. We didn't stay too late. Covered a lot of robot territory. Kind of focused on lawn mowing robots. Didn't plan that, but it was a lot of fun. So, anything else before we close the meeting here? Our business meeting is the first Wednesday, so that'll be October the 4th, where we talk about mainly presentations. So if we don't have any other show and tell, I make a motion this meeting be closed. Have a second? Second. All in favor say aye.
Aye.
Those opposed say nay. Ayes have it. Meeting adjourned.
Turning off the recorder.
We had fun. Hey, turn off